We go with the third and final version of the belt feeder. The housing is completely covered with thin metal sheets and the control panel can be operated from the rear side, where the main switch is on the left and the control display on the right. Nearby located are the adjustment screws for the belt tension and two side bearings to hold the belt in center position. Glued rubber strips travel through the underside of the hopper to help with the material transport, and all side elements are chamfered, which prevents material residues. To avoid the shredder from clogging, the material flow stops when it reaches the light barrier. From this point on, the belt waits 10 seconds and restarts for 1 second as long as material is detected. This leads to only small proportions of material released in the shredder. Waiting and feeding time can be adjusted via control display. Now let's have a look at the cabinet where all the electrical components are located. So we start with the electrical connection terminal, the circuit breaker, 12-volt power supply, 5-volt power supply, shredder power relay, shredder reverse relay, measurement of the shredder motor load, sub-relays for power and turning direction. Here we have the conveyor motor driver. And then we go to the ESP microcontroller, which is the brain of the machine, next to a level shifter and a snubber bag. Time for a short live demo. The hopper is filled with bottle caps, which we don't want to shred by ourselves, so the machine can do the job for us. The basket of flakes proofs already tested a lot of material, and here we will start with 70% belt speed with the shredder already running. The caps begin to move in outlet direction, and as you can see, it really helps to have some sort of strips on the belt to convey more material. The small black plastic flap on the outlet helps to prevent too heavy material accumulations. When the first caps arrive at the light barrier, the belt stops for 10 seconds and restarts for 1 second to get only small proportions of material fed to the shredder. Let's fast forward to the hotspots. Caps aligned on the outlet, ready for departure. From here you have quite a good view to the 10-to-1 cycle, which by the way can also be adjusted at the control display. 10 seconds waiting time is a little bit conservative, but testing showed sometimes you have only 2 caps, but from time to time there are up to 10 caps for which the shredder needs some time to process. Okay, let's test the overload protection by throwing in too many caps, and here it goes. The load, or so to say the motor current, reached a limit, which then triggered a stop of the shredder with subsequent reverse routine. In detail, the belt feeder controller tries to get rid of the overload situation by stopping the shredder and doing some reverse turns, followed by some forward turns. When the routine is finished, the motor current is measured again to make sure the overload is gone, and in the meantime the belt stops feeding material completely. From the cabinet point of view, the main relay is stopped, then the reverse relay is activated and the shredder is powered again. When the reverse turns are finished, the shredder stops again, is switched back to forward and starts again.